Hello, how are you? I'm sad to hear that you'll have to stay at home for another 2 weeks. So all must remain strong to face this trying time. Okay? And please focus on your study because your examination, SPM, is around the corner. So waste no time and stay at home. Today, I would like to discuss something about electric current and potential difference. They are both very important. And of course, you need to know the meaning of resistance as well as the Ohm's law. Okay, let us begin with electric current. So, what is the meaning of electric current? The symbol is I. It's defined as the rate of flow of electric charge. So the SI unit for electric current should be ampere. Capital letter A, or you can say coulomb per second. The reason is charge is measured in coulomb and the time is measured in second. Okay? All right. So, who carries charge? Electrons and the ions, like copper ions, hydroxyl ions, sodium ions, either positive or negative. So the flow of the ions or the flow of the electrons will constitute current flow. But there's one thing I need to emphasize. Let's say you're given a lamp. Okay, there's a lamp. So the current flow from left to right, 5 ampere. In this case, the flow of current is not caused by the flow of ions, but it is actually caused by electrons. And please remember, electrons carries charge, okay? So the charge for one electron, no need to memorize this, it will be given in the exam, minus 19 coulomb. So, how are you going to find the number of electrons passing through the lamp, let's say in 5 minutes? Later we want to calculate. But another question you will start asking, in which direction that the electrons are flowing? Many will think it's from left to right. No, it is actually from right to the left. Always opposite to the current flow. Why must the scientists make such decision where current flow is always opposite to electron flow? Actually, there's a long history for that. We don't need to spend too much time on this thing, okay? But they have their reason to say so. All right, let's see how we're going to calculate the number of electrons passing through the lamp in 5 minutes. So in order to solve this, you must check how much is the charge flowing. It should be given by this, right? Where the current is 5 and the time is 5 minutes. But can you write down 5? No, you need SI unit, which is in second. So you multiply 60. So what is 5 times 5 times 60? 5 times 5 times 60, you should get 1,500 coulomb. So to calculate the number of electrons, N, number of electrons, you need to have the Q divided by the charge for each electron. So it's a 1 1500 divided by 1.6 negative 19. So I have to calculate. So 1500 divided by 1.6 negative 19. Oh, they give you 9.375 10 to the power of 21. This is not. The number is huge, okay? The number is huge. Okay. The second thing is you need to know the meaning of potential difference. This is very important. Sometimes you can call it voltage. They're the same, okay? Of course, they are measured in volt. All right, they are measured in volt. And we define potential difference as the work done divided by the charge. So, the SI unit can be either written as volt or, based on the definition, work done is in joule, charge is in coulomb, C minus 1. Well, a lot of students will ask, what do you mean by work done, sir? I don't quite understand, okay? Don't worry. You look at this particular example, you should be able to get a very good idea. Okay, I'm going to draw. There's a lamp here. Change the color, okay? Change to yellow. And then you have ammeter. And you need a voltmeter. Thank you. All right. So now let's say the current flowing over here is 2 ampere. So of course the ammeter should record a reading of 2 ampere. But the voltmeter reading is 6 volt. Okay, that's a good one. What is the meaning of 6 volt? What's the meaning of 6 volt? So definition states that V is W over the Q. So how to get 6 here? As simple as 6 divided by 1, am I right? So here it actually means, the meaning of this is 6 joule of electrical energy is converted into, for a lamp it will be heat and light energy when, see this, 1 coulomb of electric charge passing through the lamp. So you can see that in definition they use the word work done just to simplify this whole long sentence. See that? So you can actually define potential difference as, if you don't like the word work done, then you can always say it's the electrical energy converted. Yes. So in this case, it's the electrical energy converted into heat and light. You got it? So for a heater, electrical energy is converted into heat. That's all. There's no light. Quite easy, am I right? So, for current flow, you actually need a battery. What's the role played by the battery? The role played by the battery is to set up a potential difference across any component. In this case, the positive potential will set up high potential at one point, and the negative terminal will set up a low potential at one point. And current will always flow from high potential point to the low potential point. It's just like water can only flow from high level to the low level. You don't expect water to go up unless there's a pump, right? A water pump. Okay? Okay, the next aspect that I need to talk about is electrical resistance. We define electrical resistance as the ratio of voltage to the current. Now, let's say you are given a lamp, okay? Beautiful lamp. And the current passing through before is 5. Most students thought that after should be less than 5. No, it must be the same. Just like the amount of blood goes to your heart and the one living has to be the same. If not, your heart is going to explode, okay? And by putting a voltmeter, you get a reading of, let's say, 12 volt. So, how do you calculate the resistance? Definitely it's a 12 divided by 5 to give you 2.4. What's the unit? By definition, it's a volt per ampere. But you will rarely hear people write down as volt per ampere. They prefer this, the ohm, okay? The O, the H, and the M. So, from this relationship of R equals to V over I will say your V is directly proportional to I if R is fixed merit. So meaning that if you apply a bigger voltage to the lamp, you expect the current to increase. So in this case, if I ask you to sketch a graph of, V versus I, what type of graph is that? So I expect you to get a straight line, am I right? True? But electrical resistance of a conductor, electrical resistance of a conductor depends on a few important factors. The very first one, the R, depends on the length of the conductor. So if you are sketching R versus the L, you expect what? You expect a straight line. What's the meaning of straight line? That means it's directly proportional. Meaning that when L is double, R is double. So when you make your conductor longer, you have bigger resistance. Just like a road, a longer stretch, you need more energy to finish the stretch, right? Okay. Look at second factor. R depends on the cross sectional area, or we can just call it the thickness, okay? The symbol is A, of course. So how do you sketch the graph? R versus A. And don't make this fatal error. It's not a straight line down. It's wrong, okay? So the actual one got to be this way. Hyperbolic. R versus A must be a curve. And if you're good in mathematics, you know that R versus 1 over A got to be a straight line. This is the second factor. And the third factor will be R depends on the type of material. Look at these two conductors. Quite clearly, they are same length, same length and same thickness. Same length and same thickness. But this is the nickel, this is copper. So who will offer more resistance, even though they have same length and same thickness? And not surprised, the nickel will have more resistance than the copper. That's the reason why both the connecting wires and the tungsten filament in the lamp carry the same amount of current, but the filament is extremely hot. But the copper conducting wire is not so hot. Why? Because the resistance of the tungsten wire in the lamp is very, very large compared to the copper wire. Okay? Number 4, you'll find that R depends on temperature. But different material responds differently to temperature change, okay? So you have to see the 3 different materials. 1, 2, 3. You need to have a common 0 here. And this is all resistance. For normal conductor, let's say tungsten, this is temperature. Resistance will go up. This is tungsten, okay? Whereas for thermistor, a type of semiconductor material, resistance will go down. But constant wire, it will be constant. Oh. It's an alloy, okay? I think it should be a nickel plus copper. It's an alloy, nickel plus copper alloy, where you see that resistance is constant. All right? So there are altogether 4 important factors that can control resistance. Number 1 is the length. Number 2 is the cross-sectional area. Number 3 is the temperature. And number 4 is the type of material. When I say inversely proportional, it means when you double your cross-sectional area, you don't double your resistance, but you half it. Now, the last one, the law, the Ohm's law. To verify Ohm's law, you need to carry out a simple experiment where you need the ammeter to read the current, and you need a rheostat to vary the current or to vary the voltage, and your specimen should be connected between the 2 points. And you need to have a voltmeter. So by changing the current, the voltage will respond accordingly. And you can plot a graph. Let's say you want to plot a V versus I graph. Ohm's law states that the current passing through a conductor is directly proportional to the voltage applied. But that's the catch. Temperature must remain constant, and thickness and the length also must remain constant. You can keep the length and thickness unchanged, but you cannot control the temperature, am I right? So it looks like not many material can obey the Ohm's law. The only material I think that can obey is the constant ton, because the resistance won't change. Therefore, the gradient of V versus I graph also must not change. So it should be a straight line. Yeah, this is called the ohmic conductor. Remember, resistance is V over I, right? So it can be found from the gradient to get the resistance. But for most material, you don't get the kind of straight line. And therefore, they are considered non-ohmic. You can actually plot either V against I or I versus V. It's okay, no issue here. Okay, if you are using tungsten wire, as I said before, for tungsten, temperature up, resistance up. So you expect the gradient to become sharper when current increases. Because when current increases, temperature will increase, so resistance also will increase. So both sides curve this way. Sharper gradient means resistance increases. But if you are using another type of wire or material, let's say you choose a thermistor. The behavior of thermistor is such, when current go up, temperature go up, but then resistance will come down. So you expect the gradient to become smaller when current increases. So if you don't get a straight line passing through, then they are called the non-ohmic conductor. Okay, so I hope today's lesson can clarify 4 important things: electric current, potential difference, Ohm's law, and also electrical resistance. So I hope that you enjoy learning, and I will see you again. Bye-bye.